Welcome to Career Tools. This is Wendy.
And this is Amanda.
Today's cast, Data Analysis for Beginners, Avoid Common Mistakes, Part 1.
The questions that this cast answers are: what should I watch out for when analyzing data? What's wrong with my data? And what alternatives to data are there?
If you want the answers to these questions and more, keep listening.
In June, we're offering a virtual effective communicator training on June 24th at 10 a.m. Eastern, as well as a virtual effective manager conference starting June 9th. And if you'd like to see us in person, we're coming to San Diego, Seattle, and DC. Sign up for any of these options at managertools.com/training.
The best decisions in companies come from data. Making decisions based on something you actually know rather than gut feel is what everybody says you should do. If you use data to inform your actions, whether it's data about yourself, like what you've been doing in your own productivity, or data about customers or products or whatever it is, you're more likely to be successful. And you're also more likely to be able to persuade people to do what you think they should do if you have data for that. And therefore, you're more likely to be successful overall. But not everybody is data literate. And it's a bit like nobody taught me how to look after money when I was at school. They don't really teach us data literacy either, or at least they didn't when I was at school. Maybe they do now. But there are some common things that people do with data that they don't realize is making the data inaccurate and therefore messing up their decisions. So understanding what those common errors are and avoiding them helps your data be more accurate and therefore make better decisions. And also being accurate and having the right data and not having those common pitfalls in it gives you more credibility. If you have the right data and people can't pick holes in it, they're much more likely to believe you and be persuaded to your point of view. So in this cast, we're just going to talk about some common pitfalls and how to avoid them.
So what we're going to talk about is, first, check with reality. Then dig for assumptions, followed by check data quality, then check for biases, and lastly, avoid using data when ... Yeah,
we'll keep that one till the end. Tease everybody. So the first rule is check with reality. It's the first rule when you're working with any data. We could have named it the common sense rule, but plenty of people say common sense isn't common. So we went with check with reality.
When we receive data from whatever source, there's an assumption that it must be accurate, purely because it's data. We think that because it came out of a computer, it's formatted, it's dense, and it's numbers, it must be right. Following that false assumption means that grounding of all of your analysis is wrong, and you have no hope of getting useful information from it. This is what the phrase garbage in, garbage out means. If you start with garbage data, you will not get any useful information. You'll just get more garbage.
Yes. When you first get your data, what you want to do is ask really high level questions about, does this fit with the reality of what I know? So for example, if you think of an aircraft taking off from an airport, let's use New Orleans because it's right at the south. If that aircraft is heading for New York, and once they get out of, the airport control zone where they're told where to fly, they need to be heading north. If you're going from New Orleans, which is in the south of the US, to New York, which is north, you have to be flying north. If you're flying west or east or south, you're doing it wrong. And that's kind of what you're looking at for your data. You're looking at the highest level data, the highest level picture. Does this make sense in the reality as I know it?
And just for another example, think if patient stays in a hospital have consistently averaged 3.2 days for the last 30 weeks, and there have been no protocol changes, the likelihood of the average suddenly jumping to 12.5 days this week is low. When you look at consistency in the data at the highest level, there should not be significant outliers. You'll want to rerun the data to see if the anomaly is still there. And if so, do more research on that anomaly before spending significant time analyzing the data set.
So if you're looking at your personal productivity and you were getting through 10 tickets a week for the last 30 weeks, and last week you got through 30, it's probable there was something wrong with those tickets, or the ticket counting system, or your counting system was like, well, wait, before you think, yes, I've increased my productivity by 30%. I don't even know if that's right. That's how good I would have to check that. Is that 30% or not? Anyway, before you think, oh, I've had a significant increase in productivity, you want to go check that count again.
And if your data is prone to seasonal trends, check to make sure that they make sense. Think in the tourism industry, a spike in January bookings for coastal Maine beach resorts is going to be highly unlikely.
It's too cold to sit on the beach.
It's too cold. A spike is going to be probably inaccurate. Now, on the other hand, a spike at this time in the airline industry could absolutely be correct, since travelers often book winter getaways to warm destination months in advance to get the best fares, because in the winter, we're looking to go to warm places, and that's when they book.
It's like if you have data with free trials and then purchases. If you've got a bunch of data that says the purchase came first and the free trial came afterwards, that's probably, there's something wrong with the data. It's really high level questioning of whether or not this makes sense in the reality of your life. The other thing you want to do is cross-reference your metrics. So if there's a software development productivity increase of like 35%, then you should see a corresponding improvement in completion rates or a reduction in development time. If there's an increase in sales, then you should see an increase in money in the bank account, right? That should be coming through to your bank account. So if you have two related pieces of information, or if you have a piece of information like sales, and then being able to check it against the actual money in the bank account or whatever, if you have sales confirmations, you want to be able to check, like, are there transactions that match with those? And then that starts to validate the data that you have.
Now we're going to talk about how to dig for assumptions. Before you rely on data, you're going to need to dig for assumptions. This isn't because assumptions necessarily kill the value of a data result. There are no data sets without assumptions baked in. Rather, you're going to be asked, and you need to know to help you and others understand the potential for skewing the results. So you want to know what assumptions you're making and how that's going to impact the potential on your results, because we all make assumptions. We can't help it.
Yeah. And the data is collected with assumptions in it. Like, errors and bias are introduced to data when it's collected, both intentionally, because we say, okay, I'm using this data because I don't have any other data, or I'm using data from the last 3 months because I don't have anything older. That affects the results that you're going to get. And sometimes you can't help that. And sometimes there's unintentional biases in the data, or there's unintentional assumptions baked into the way the data is collected. But knowing that and knowing what effect it might have on the results that you're looking at, that's what's important. You know, when we think about collecting data, we make assumptions about what data is required and how it might be formatted and what can be measured or ignored. I was working with some data, sales data the other day, and the data I had dates on it, which was great. Like, I wanted to sort like the order of orders by date, but then there were a whole bunch on the same day, and I needed to be able to sort those in order. And so I needed the time as well. And nobody had thought when the data was collected, oh, we might need the time as well. So we didn't collect it because we had no idea that when it got as far as me doing the analysis, that we might need the time as well. Those decisions that we make create limitations in the data set, and they might cause bias because we're only collecting a certain amount of data or from a certain source. Like, if you do any podcast research about how successful podcasts are, nobody ever knows, because we can't tell how much you listen on your device. Once the podcast has been downloaded, we can't tell how long you listen for and whether you listen to the complete podcast. And no podcaster can, unless they have certain things that we don't have for reasons. But in the majority of the cases, it's really hard to know whether or not podcasts are being listened to. And that means that the data that we have from our website is necessarily biased because we can't get more data. So the choice is about what variables you track, which populations to sample from, even the way if you're doing a survey, the way you ask questions can affect the data that you get on the outside. And all of that means that you could have misleading conclusions when the data is analyzed, there could be 50 reasons and you've only thought of 2 of them. And some of those 50 you won't find because you didn't collect the right data in the first place. And that's not necessarily because you didn't, it's because you couldn't or whatever, or you made choices because data collection is expensive in resources. But knowing that so that you can look at the results in light of that, that's what's important.
Yeah. And those of us who create and work with data never think of ourselves as the source of the assumptions, or at least we assume that everyone else has the same set of assumptions that we do. So, for example, if you're looking at the success of an email campaign, we might be asked, how effective was the campaign? We would present the data that shows the proportion of customers who made purchases after receiving the email. It's pretty straightforward. But it would be easy to present the data that's based only on customers who open the email, because clearly we can't judge the effectiveness of the content of the email when a customer didn't see that text.
But then if you're looking at that data, if you have that assumption, I'm going to tell you that 43% of people bought the product after seeing the email. And I mean, of the people that 43% of the people that opened it, and the person I'm talking to thinks I mean 43% of the number that we sent it to. That's a huge difference in revenue potentially, as well as every other step all the way through that. So knowing that, you could make decisions based on that data, with one person having that, knowing that they meant the emails being opened and the other person mean the emails that were sent. And that could drive all sorts of actions in an organization and send you all off on a wild goose chase potentially.
So when presenting the data, it's good practice to list all of assumptions ahead of the data. For a weekly team meeting reviewing the same metrics each week, you probably will not need to discuss them weekly. You might, however, want to review these assumptions quarterly to make sure they're still valid. For those one-off presentations, the approach should be different. Reviewing assumptions before people see the data means they're more likely to believe your conclusions and be persuaded by you. So give them the assumptions, that information ahead of time so everyone's on the same page, because even how we look at data can come from 2 different perspectives. And if it's something that you do weekly, you will have to remind people, because how we started something is not how we got there. So even quarterly, keep that at the top of your mind, that every now and then you want to just make sure everyone's still on the same page, because sometimes we forget what we're supposed to be looking at.
Especially if it's your data and you love it and you're in it every day, and somebody else is only reviewing it weekly and it's not part of their job. They're just listening to you. Like, they're not keeping in their brain all of the assumptions for the whole time. And also, quarterly is a good time to review them and think, okay, has the situation in which we're collecting this data or the way it's being represented and so on, like, has that changed enough to change my results? Because that happens too.
Yeah, and Wendy, this literally happened this morning in our meeting when I was presenting data. Someone's like, we don't know what you're talking about. I was like, okay, yeah, I need to re-explain this and present it more effectively, because people were taking it 2 different ways. And that was on me for not reminding people as I make changes, because it makes sense to me, but
exactly,
everybody
because
else,
you're in it and you knew exactly what it was and all of that. Yeah, exactly. Yeah. And that was marketing data. And one of the things that really affects data is algorithm changes. And so you could be looking at data that says, hey, 50,000 people came to our website every week for 3 months, and then it goes down to 20,000, and think, oh my gosh, we've done something terribly wrong. And it can be that the algorithm changed. And it's different actions to take if the algorithm changed than if you think there's something else that caused that precipitous drop.
Mark will be delivering our October public conference, the 28th and 29th, in London this year. If you're in the European theater, this means that you can enjoy stateside pricing of $20,000 per training day for up to 30 of your professionals with no extra travel costs if it's scheduled close to this last week in October. And you'll get Mark. This is for any of our core training options: effective manager, senior manager, communicator, hiring manager, etc. And some of these events come with full licensing. So contact Maggie, customer service at manager-tools.com to discuss availability and lock in your date.
Once you've checked your data for reality, does it match with the reality that you understand? The next thing is to check the data quality, the numbers on your page. And a spreadsheet with thousands of rows of data looks like good data, but it can be easily hiding issues that throw off your analysis. So we've got some questions to ask.
First question, is the source reliable? This does not just relate to the person who gave you the data, but also the system by which the data was collected. For example, if individuals are typing their email addresses into a form for your data, you can guarantee that there are going to be typos, entries which match the validation, but which aren't actually real, so fake emails, or addresses that no longer exist, and so on. If someone is typing into a form, there's going to be human error, or maybe not an error, people purposely giving you wrong emails, because we don't want those extra ones in our inbox. So make sure that the data is scrubbed before you can do any analysis with it. So don't just trust what you get. You have to double check it.
So the next question is, how was the data collected? And obviously, if people are typing into a form, there's human error is there. But even data that's collected automatically is fallible. One of the many jobs that I did in my 20s was I worked in the office management suite of a shopping mall. And I discovered there's things in stores called footfall meters. And basically, it's a camera at the door, and it counts how many people walk through the door, which they call footfall. And that's a measure of how many people, how popular a store is. And they use it for popularity of like different times of day and whether they should be open longer or shorter or different times or whatever. So you can imagine how that data could be inaccurate, right? Staff come in and out the door. You don't want to count those because they're not customers. Some customers will forget something in their car and they'll come in and out the door several times because they had to go back and get their money or whatever because they couldn't pay. And that's one visit, but the system counts it as several visits because they've gone past that counter several times. If maintenance is working on the doors, no data is being collected. So you'd have a big gap in your data. And then there's power outages or system failures. And I think when I was doing it, they were probably fairly manual. I bet now it's all software driven. So you can have software faults, you can have updates that don't work properly. All of the things that you experience on your own computer happen on these kind of systems. So if you've got a data set that's a whole year, you could have gaps in it or places where the system counted everybody twice for no apparent reason, or all sorts of things that you can't see because you've got hundreds of thousands of lines of data. You have to go through and check it and make sure it's good data. Otherwise, you're just going to get garbage.
The next question that you want to ask is the data consistent within itself? Data should be internally consistent, meaning all the data points in your data set agree with each other according to rules and relationships that should govern them. So, for example, if one field says a customer made a $500 purchase, then their order should be $500. Their account balance should reflect this transaction, and inventory counts should adjust accordingly. If your business rules state that orders cannot be shipped without payment, then any data showing shipped orders should have the corresponding payment records. Time sequences should make sense. The payment date should be dated before the shipping, if that's the rule. So does it follow all the rules? Does everything match? Does it all make sense in the process? These are things that you have to check within your data set.
Otherwise, you get like several hours in and go, why doesn't this make any sense? It's because you didn't start with good data. And if you're a data analyst, all of this is like, I do this without breathing. But if you're not, and you only occasionally deal with data, then hopefully this is good reminders of basics. So the last one is the data complete? When data is copied and pasted, it's really easy to miss some lines at the bottom of a spreadsheet, or miss them because they've been filtered out of the data, or even paste in data from a different day or a different copy. Our email provider gives reports, and the names of the reports are completely random sets of letters and numbers. I have no idea. I'm sure they mean something to someone somewhere there, but I would like them to say this email sent on this date to these people, but they don't. And so if I have 5 and I downloaded them all at once, I don't know which one is which. So then I have to delete them, download them one at a time, and rename them before I download the next one, because otherwise I can't tell which is which. And it's really easy to do that. It's also worth checking that you have all sources of data. So if you were, for example, taking data from representatives who were knocking on doors, you can tell that that's what happened while I was writing this podcast. People knocked at my door. But, it seems that knocking on people's doors and asking them if they want various things done on their houses is very popular at the moment. If you were taking data from those people, have you taken data from every single person who was out that day? Because if you only have 45% of the people, then your data is going to be skewed. And again, that's a really basic question, but it's not one we think of if we're diving into it and thinking, I'm ready, I've got some data, I can get some conclusions. And then you just end up hours in and without good results. And then you have to backtrack and redo it all. Not that I've ever done that, obviously. That I know
I did that this week.
Hey.
I'm the new person to the data collection game. So this is all really relevant to my life currently.
And again, if you do it every day, and then you don't make these mistakes. But those of us who do it infrequently or have only just started make these mistakes. And you soon learn not to make them. The moment I've downloaded 2 spreadsheets from our email provider and I see the names, I'm like, oh God, I shouldn't do that. I should rename them before I download them. And I know that.
Yeah.
Eventually, if I did it frequently enough, I would remember, but I don't.
I would also say, even if you do this every day and it's become pretty routine, if you have to switch up different types of data that you're collecting or looking at, this is a good refresher of remember these things before you dive into a completely different type of data, because sometimes that puts our bias or those assumptions that, are on us because we're used to doing something else. So think about that. If you're starting a brand new project with completely different type of data that you're going to be taking, that it's worth a step back to go back to the basics as well.
Exactly. So that's giving you some things to look at with your data this week. Next week, we'll be back with a couple more common pitfalls that hopefully you won't fall into between now and then. Bye, everyone.
Bye.